So we're going to look at two new rules about circle geometry here. And our first one is going to be about tangents. So I'll put a line to break between these two. So we'll look at the first one first. So at the point of contact on a circle, the angle between the tangent and the radius is 90 degrees. So what we mean here is that if I have a circle, keep in mind that the radius is always the part of the circle, a line on the circle that goes from the center to the edge. So this is always center to edge. And a tangent is a line that comes and just kind of rests on the edge of the circle, so it doesn't actually go through it, and it just touches at that one single point. So it's similar to if you had a soccer ball or a hockey ball on the ground could be the tangent, and you'd have the one point where the ball is actually touching. And if you drew a line from the center straight down as a radius, you'd get a 90-degree angle in that corner. So that's what they're saying here. Between any tangent and the radius, you get an angle of 90 degrees. So again, a tangent is just a line touching the circle at one point, and the radius is from the center to the edge, and you get 90 degrees. And our abbreviation for that is tangent. That symbol means perpendicular to the radius, which means it'll be 90 degrees. Our second rule is angles in a semicircle is 90 degrees. So what I mean by semicircle is, think about cutting this circle in half. Right? So if we cut that in half and we make a triangle using the diameter there, the half the circle part of the triangle, this corner up here becomes 90 degrees. So angles on a semicircle in that upper corner of that triangle will become 90 degrees. And so we could look at another example. If I did one on an angle, there's a line going through the center to make a semicircle. And if you think about making a triangle using those, that will always be a right angle triangle in the corner. So we take a look at two examples of how these apply. Look here at number 1. I notice that I have a semicircle. I have a triangle that's using the diameter, the center of the circle. So I know that this corner up here will be 90 degrees. And then I have angles in a triangle add up to 180. So 180 minus 90 minus 53. And we get 37. So x is equal to 37. Looking at our other rule, with the tangent, here we have a tangent situation. So this is my tangent to the circle, and I know that any tangent will make a 90-degree angle to a radius. And again, a radius is always a line from the center, shown by the dot there, to the edge. So those two angles together should add up to 90 degrees. So to find x, I would go 90 minus 63, and you should get 27 as your angle. So in that case, x is equal to 27. So again, here I'm looking for a tangent which goes from the center to the edge, and my radius. So the radius from center to edge, and the tangent is just touching. So I know I have a 90-degree triangle in that corner. And that's the application of those two rules there. And one thing to keep in mind with the radius of a circle is that the radii are often equal, or should always be equal. So all radius will have the same length. So from the center to the edge and from the center to the edge will always be the same length. So this here makes an isosceles triangle. So the radius will always be equal. We say radii are equal, and you can get an isosceles triangle, which we know, we'll just say isos. That's not good. Isos triangle. So you know that you've got the similar rules where the base angles of an isosceles triangle are equal.